Finishing up this section 2.2 of the textbook, we're going to take a look at piecewise function. The definition of a piecewise function is that it's a function that's defined by two or possibly more equations over specific domain. So in other words, depending on where you are in the domain, there's going to be a particular equation that applies. An example from real life of a piecewise function can be cell phone bills, or in particular my family's cell phone bill. We're on a family plan and we share data. So our cell phone bill starts off, we share 3 gigabytes of data for $40 a month. So when we are in the domain, which is my gigabytes, my X, anything up to 3 gigabytes is this flat line here of $40 a month. Okay, so our equation, our function is a straight line. Once we go over this 3 gigabytes, the monthly bill shoots off like that. So two different behaviors depending on where you are in your domain. Going back to our notes that I emailed to you that you have now. Again, the definition, it's a function defined by two or more equations. And again, there's this idea of a specified domain. So you have to pay attention where you are in the domain. This example here, I didn't get the curly Q brackets in, so if you would put those in right now. And this says that our function f of x is equal to 3, or our function is x minus 2, two totally different behaviors. And the behavior all depends on where we are in the domain. If x is less than or equal to -1, that's when we're at y is 3. If x is at greater than -1, that's when we're at x minus 2. So always in a piecewise function, there's going to be very critical values in your domain that are going to be the boundary points, if you will, between two different functions that are going to take place. One thing that we're going to do with piecewise functions is use them to evaluate certain values of x. Here we're told to look for f of 0. First thing we have to do is find where 0 is in our domain as regards to these points of -1, just -1. Is 0 bigger than -1, or is it less than -1? So 0 is, of course, bigger than -1. So for f of 0, the equation we're going to use is x minus 2, which is 0 minus 2, which is -2. So for f of 0, we're at -2. Now take a look at f of -2. Again, we have to consider, where is this -2 in regards to -1? Is it less than or is it equal to? -2 is less than -1. So we're going to be in this part of our piecewise function. So our y value is going to be 3. Last one is taking a look at f of -1. X is -1. Going back to our equations here, we see that if x is less than or equal to -1, so here, yep, we're equal to -1, so our 3 is going to be the value of our function. Something else we're going to do with piecewise functions is to graph these. So let's take a look at this part of our graph that says f of x is 3, y is equal to 3. So here's y is 3, 1, 2, 3. And so our line is going to be here someplace. Now, we know we're going to go on indefinitely here because less than, but we need to consider what's going to happen at -1. So notice I just stopped randomly here. Here's x is -1. So we're going to be approaching this -1 here. And now at -1, is this 3 included or not? This less than or equal to says, yep, it's included, so I'm going to have a closed dot there. So that's the graphic representation of this piece of our function. Now we consider x minus 2. This is a straight line. So graphing this, we can look at y equals mx plus b. In this case, y is equal to x minus 2. M is our slope 1, and b is negative 2 to graph a straight line. So we go to our y-intercept of negative 2, and then our slope is positive 1. So slope is 1 over 1, so we're going to go up 1 over 1, up 1 over 1, and so on. And there is our straight line. Now, I started this straight line at the y-intercept, but we have to continue because our straight line theoretically goes down here. However, because negative 1, x is negative 1, is the point that distinguishes between the two behaviors of our graph, I'm going to continue this line down here to negative 1. This will be an open circle, however, because it's only, this line only holds for x bigger than negative 1. Next example here, again, if you would put in your curly cues, we'll take a look at graphing this. Y is going to be x if x is less than or equal to 0. So in this situation, the value that's going to determine in our domain where the different behaviors are going to set in is going to be x is 0, or a y-axis. And let me graph these. So here, when x is less than or equal to 0, we have the straight line here, our x-intercept. Let's take a look. Y equals x. So our slope is 1, or 1 over 1, and our b is 0. So in this case, we would have our x-intercept, and now our slope is 1. So we would go up 1 over 1, up 1 over 1, and our line would be something like this. Now, because this is less than or equal to 0, we're going to stop here. And this line here is not going to happen. So that part of the line doesn't exist for this particular function because this is only good for x's less than 0. Let's take a look at this equation now. Y equals negative x. Our slope is negative 1, which would be negative 1 over 1, and our b again is 0. So to start to graph, we go to our y-intercept of b. In this case, our slope is negative 1 over 1, so we would go down 1 over 1, down 1 over 1, down 1 over 1, and our line would be going like this. And if we were to continue the line, this would be our entire straight line. As in the first piece of this function, we're not going to consider that because this negative x only happens for x greater than 0. To finish this example off, let's take a look at finding f of 4. We want to find out x is 4. 4, where is that in our domain? Either greater than or less than 0. Well, 4 is bigger than 0. So it would be this. That would be the equation that we use, which would be negative 4. So for f of 4, we're at negative 4, and from our graph, we can see that.